Alright, so we have this problem here that I've written out. This is a fish swims at a speed v relative to the water against a current of 5 miles per hour. Using a mathematical model of energy expenditure, it can be shown that the total energy, E, required to swim a distance of 10 miles is given by the function E of v equals 2.73 v cubed times 10 over v minus 5. Migrating fish try to minimize the total energy required to swim a fixed distance. Find the value of v that minimizes energy required. Alright, so what we're trying to find is our value v that minimizes the energy that it takes to swim a distance. So we take our TI-84 or 83 or whatever you have, as long as it's a graphing calculator, and you come in there and you type in your function. So we say you hit y equals and you type your function in there. 2.73. That's the 6. 2.73. Our independent variable. Here it's v, but we'll say x here. Raised to third power, or cubed, times 10 divided by v, or here again I'm using x because that's a variable in the calculator. It doesn't matter what you use as long as it corresponds to the one over here, minus 5. So then we graph it. Let me move it over here so you can see better. So you see what we get, and I'll show you my window here so you can get the same thing if you wanted. Oh, here's negative 8. Yeah, alright. So for the window, I have negative 8. For the x min, x max is positive 16. The x scale is 1. The y min is negative 13,543. And the y max is 18,259. And the y scale is 1. So if we go into our graph here and we look at it, and we look at our question is what value v that minimizes the energy. Find a value v that minimizes the energy required to swim a distance. So what is v? V is our independent variable. So our independent variable, we can tell this by if we look at our function here. Inside the parentheses, our independent variable, and this is our dependent variable. So our independent variable is going to be on our x-axis, right? This axis right here. And our dependent variable, or the output, is going to be on this y-axis. So if we look here, we have some positive v's, which is good. We want, because v is a speed relative to the water. You can't have negative speed. So if you had negative speed, you'd have positive energy over here, but that doesn't make any sense because you can't have negative speed. Over here, we have positive speed, but we have negative energy. And that doesn't make any sense because you can't have less than no energy. So the only part of this graph that really makes sense is this part up here. So that's what we're going to focus on. So again, we want the value v that minimizes the energy required. So the input that gives us the smallest output. So right here we can tell that the smallest output is probably somewhere around here, right? Somewhere around here. So then the smallest input would probably be a value right about here that would correspond to it. So how we figure that out with our TI-84 or 83, whatever graphing calculator you have, might be a little different if you have an 83, because I have an 84, but it's generally the same process. You're going to hit second, and you're going to hit trace, so it brings up the calculate menu. And you're going to go down to minimum, which is number 3 here. And once you hit your minimum there, you're going to take it over. You're going to take it over here, and it says left bound question mark. So it wants you to pick a bound that's to the left of where you think approximately that the lowest value or the minimum value is. So I'm going to say over here, I'm going to hit enter. Now I want to right bound. So I'm going to go over here to the right side where I think approximately that value is. And I set it up there, and then it wants a guess, so I'm going to just put where I think it is approximately. I'm going to say right here, and it's going to say down here what your input is. So in this case it's our V, so we'll say V equals, well, we'll say V, and then we'll use the squiggly lines, right, because this denotes approximately, and we don't know exactly what it is because the calculator probably rounded it to 7 places or so. So we'll say approximately, we'll round it ourselves and say 7.5. And then for the output, we'll say E of V is equal to 4606 point, I didn't mean that second 6 right there, so 4606.875. And let me get a new piece of paper and I'll write it on it again just to make it look a little better. So our V here is equal to, or approximately equal to 7.5, and our output, our E of V, is approximately equal to 4606.875. That's it, and this would be our answer, right? Because it wants the value of V that minimizes the energy required to swim a distance, and so this would be the energy required. That is the minimal energy required. And this would be the speed that gives you that minimal energy.